So the title has changed. It's Home Food Production and the Shift to Processed Food. This is a joint paper with Tom Crossley, Rachel Griffith, and Michelle Jean. In this paper, we investigate the shift away from home-cooked food towards processed foods in the UK, where processed foods should be understood as food that goes straight from the shop to the table, as opposed to home-cooked food, which require time as well as ingredient for preparation. There's a number of reasons why we might be interested in what drives dietary choices. First is the fact that these changes in consumption have been concomitant with increase in diet-related diseases. It is also the case that there are concerns regarding a lower quality of nutrition of children, and links have been found between the nutrition in childhood and later life outcomes. Finally, beyond the health concerns and the concerns associated with investment in children's human capital through nutrition, there are also concerns that these changes are part of broader pattern of changes in lifestyle which affects informal transmission of human capital, for example, around the dinner table. And as such, dietary choices of households are part of much debated societal changes, and understanding the mechanisms of these changes is part of a broader agenda on the breakdown of the family. Our agenda in this specific paper is to investigate the role of possible causes in the increase in the share of processed food on the plate. So the scale of the shift that we're interested in is documented in this graph, which shows the increase in the expenditure on processed food as a share of total food expenditure in the UK between 1980 and 2000. There is actually a much longer recorded time series, in fact, still going on for this, which records this increase. However, we focus on the period 1980 to 2000 because this is when our data is consistent. You can see that over the period 1980 to 2000, the share of processed food goes from representing about 40% of the food budget to representing about 60%, and that's a 50% increase. However, what we are really interested in is what happens in the plate. So in other words, what is the proportion of processed food versus home-cooked food on the plate? So to get a first handle on this, I have plotted the time series of the share of processed food in total food expenditure valued in 1980 prices. So in other words, this can be interpreted as the share of processed food on the plate. And we can see that it has increased quite substantially over this period. So what we're going to do in this paper is we're going to investigate the mechanisms that have led to this increase. So the first thing we do is we look at price movements, because it could be that processed food have become relatively less expensive, so that this would be driving the changes we observe. So,
do you distinguish between different qualities? Because at least from casual empiricism, it seems to be that over the last few years, processed food has become, less, much more like home-cooked food in some respects.
So, the effect of quality should be reflected in the prices. However, it might be that the series that we have for the prices only account partially for quality. This is something which I will show you a structural model. So we could use our structural model to put bounds for the quality effects. Or we could go another route, which is to go to hedonic prices. At this point, we will operate under the assumption that the quality effects are captured by the prices.
Maybe you already said, but what is the definition you're using of processed food?
Processed foods are foods that require time as well. Processed food are foods that go from the shop to the table. Home-cooked foods are foods that require time as well as ingredients.
Okay, so then lean cuisine, which is very high quality,
that's going to be in the processed food. Hopefully, these changes in quality are reflected in the time series of the prices. However, one second. However, we have limited ourselves to the study of the period 1980 to 2000, when the emergence of these products was not so salient. But I do agree that this is a concern. Probably less so in the recent period, but probably less so in the period under investigation. Yes, Costas?
I think that's you covered just now.
Pardon me?
You covered it just now.
Okay, thank you. So, is it the case that processed foods have become relatively less expensive? Well, this graph shows the evolution of the price of processed food over the period of interest relative to the price of an outside good, and this is the red line. So you see that the price of processed food has indeed decreased. However, it has not decreased as much as the price of ingredients for home-cooked food, which is the blue line, which is below over the whole period. Therefore, if prices were the relevant determinants of these shifts, what we should observe is that the share of processed food has decreased and that of home-cooked food has increased. So this is the puzzle. Yes?
Sir, but the quality of home-cooked food is assumed to stay always the same, right?
So this is, thank you, yes. We are not dealing with skills in the preparation of home-cooked food. This is true.
But it could also be that also home-cooked food has lower quality because the, genetically modified food comes to the table and those type of
okay.
things.
This is not what I'm dealing with. I'm dealing with the choice of how you're going to allocate your budget between something which you buy in the shop and you put on the table and something which you buy in the shop and you have to combine it with ingredients, with time to make something that you put on the table. That is the dimension over which we're
the price
working.
index for home-cooked food would include the opportunity cost of time.
We will come to this.
Okay.
Here, right now, what I am showing you is only the price of the ingredients, without evaluation of the price of time. So this is
in a lot of places, urban areas in the United States, large cities in the United States, actually, you don't get to go to local grocery, and you're going to find, for example, anything that is not processed food. Here, I think that's not going to capture the amount of time that people have to spend now to actually go to a place where they can buy non-processed food, right? It's literally just the dollar value of tomatoes, for example.
yes,
Right.
yes.
I can come and
We'll see.
Take up.
Yes. Yes. For now, I'm just showing you processed versus home cooked. In the empirical analysis, we distinguish between 7 types of foods. So, the puzzle of the paper is this. Why has the share of processed food increased given the movement in the relative prices? Therefore, we're going to look at 2 other possible causes for driving these movements. The first one is the increased involvement of women on the labor market, with increased labor force participation, increased hours, conditional participation, and increased real wages of women. This means a higher opportunity cost of time and less time to cook. And here are these assertions documented. So for the UK, still for the same period, you see on the graph on the top line on the left, the labor force participation rate of spouses, which goes from a little over 40% to close to 70% over the period. The hours of spouses conditional on participation increase also from around 20 to 26, and real wages of spouses increase. Meanwhile, men's labor force participation remains constant. Now, it has to be that in the face of such major reallocation of the use of time in the engagement with the labor market, there has to be reallocation in the use of time in other activities. And yes?
Do you have any time use data that tells you something about the time spent cooking?
We have the labor supply. I will come to that later. So these 3 aspects together mean that the opportunity cost of women's time is higher now than it used to be, and that there is less time to cook. A third thing we consider is the fact that over the period there has been some reduction in household size, which means there's less scope for returns to scale in food preparation. Here is a graph showing you the some reduction in household size over the period, with average household size, household size going from 4.1 to 3.9. However, it is also of interest to note what is happening in the cross-section. And the cross-section evidence I have summarized on this slide, and it is that in every year, the share of home-cooked food is positively correlated with household size, negatively correlated with labor supply of the spouse, and negatively correlated with real marginal wages. So this is going in the cross-section in the same direction. This was unfortunate. I seem to be caught in a loop. Okay. Here we were. So, in our view, these are candidate explanations. So the change in the prices, the change in the involvement of women on the labor market, and the reduction in household size are candidate explanations for what we see in how households allocate their budget between different foods. So we build a structural model which contains these features to try to explain the puzzle. So our contribution is to model the choice between processed food and food prepared at home with time and ingredients. We model household choice over time allocation and consumption, where we incorporate the trade-off between cooking and purchasing processed meals, and working to earn an income and spending leisure time with children. And the output of our model is a shadow price of home-cooked food, which incorporates the opportunity cost of time and the returns to scale to food preparation. And so I'm now going to show you the punchline of the paper, which is this graph, which reproduces the graph that I have shown you earlier, where I showed you the price of processed food, which is the green line, and yes, this line, I can't do this, and the price of home-cooked food, which is ingredients for home-cooked food, which is the blue line, which is at the bottom. So if we compare these two time series of prices, we cannot understand how what is on the plate has changed. However, if we construct a shadow price of home-cooked food where we incorporate the price of time and the decreased opportunities for returns to scale to cooking, we see that the shadow price of home-cooked food is now above that of processed food, so there is no puzzle anymore. I want to stress that this is an output of the model. This is not something that is directly in the data. We have imposed some structure to get this series. So what I will do now is I will show you the model, the data, and estimation results.
Valerie, just in terms of the data, if we looked at this by some measure of family income or something like that, what is happening to processed food versus home-cooked food? If we looked at this as a function of parents' education or wage rates or something like that, do upper SES households consume a greater or lesser fraction of processed to home-cooked food?
So what we have is that in the cross-section, we have found that there is indeed a negative correlation between the real wages of women and the share of home-cooked food. So we have this evidence there. Yes.
What about the time trend, though? What's happening with upper income and lower income families over time in terms of their share of processed food?
So, in terms of income conditional on the wages, I don't know. So we'll see that when we get to it. So the model overview is that households contain adults and children. Adults allocate time between work, home production, and time spent with children, which we call leisure. Utility is derived from consuming food, an outside good, and spending time with children. And food is either purchased ready-made or produced by combining ingredients and time. So we have here the utility function of the household, which has one part for the adults, U is the adult material well-being, another part for the children is H. The number of adults is A, the number of children is K. We have a welfare weight that households place on adult material well-being. As I have said, the households consume a food aggregate. The food aggregate that goes to the adults is F over A plus K, so we put everything in per capita terms. It will become obvious why. The food aggregate that goes to the children is G over A plus K. This is to allow for the fact that nutrition has different effects on adults and children. There is also an outside good, X, which is shared between a household member and has a degree of publicness, which is measured by a parameter theta. And finally, L is the time spent with the children per adult. Home production technology is described by a Leontiev production technology where we produce food at home R using ingredients I and time T. And time and ingredients are complements, which seems to be in agreement with what Amermesh describes. The time per adult spent on food preparation has to be scaled by a scaling factor chi, which converts time into units of food. And what we have is a Barton scaling of demographic effects a la Deaton-Paxson or Crossley and Liu. What this means is that the production of home-cooked food is linear homogeneous in time and ingredients, but not in household size. In other words, a meal that you cook for two takes less than twice the time required to prepare a meal for one. Now, this functional form for the production technology implies that total time spent cooking is given by the expression here, I over chi times A plus K to the 1 minus gamma, and the home-cooked food is equal to the ingredients. Now, the food aggregates. So we have two types of food: processed food, for example, ready meals, takeaways, and then food produced at home using ingredients and time. And that's R and C. And the food aggregates are functions of this. So think about that as the plate. On your plate, there will be something that you've produced yourself and something that you've purchased. The budget constraint is standard, tells us that what we spend on processed food plus what we spend on ingredients plus what we spend on the outside good is the sum of what we earn in unearned income plus the wage times the time that we work. So here, for simplification, we've put W as if there was, so W for a wage for the household times A, the number of adults. It would be very easy to write W1 times the labor supply of member 1 plus W2 times the labor supply of member 2. So T is total time available in the day, L is the time spent with children per adult, and T is the time per adult spent on food preparation. We can rewrite the budget constraint in per capita terms, so just dividing on either side of the equal sign by the number of household members. And this enables us to rewrite the whole problem in terms of shadow prices and shadow quantities of the goods. Now, what we have is that households are choosing on quantity of processed food per capita, C star, ingredients per capita, I star, time per children, L star, the public good, X star, but where we account per capita, but equivalize accounting for the publicness of the good. And you see that what this enables us to do is to make apparent how the structure of the model changes the calculation of those shadow prices. Because what we have here is that the effective price or the shadow price of ingredients is not only the market price PI, but a valuation of the opportunity cost of time of the women, but scaled by the returns to scale in food preparation.
So here there is no specialization
No.
in adults.
Not yet.
So going back to the previous question, if high-income households consume a lot of home food, it's difficult to explain with this model. Because I would expect if the husband has high earnings, the wife can stay at home and therefore specialize. This cannot be generated here. Or can it? Or I don't know.
I think I would rather keep that for discussing at the end. This, how we could allow for specialization here. Thank you.
But if they hire a chef, is that processed food or is it? No, seriously, they're really high income, or you bring in the catering was mentioned earlier. How do you treat it just empirically? That's kind of one way to finesse it.
Somehow, Jim, it hadn't come to my mind yet. But I'll make sure I incorporate this in the next version. So more seriously, I wouldn't expect this to be a problem for a very large fraction of households. So whilst I think it is interesting conceptually, I don't think these long-time trends are explained by such phenomena. But I will certainly think about it.
So this model doesn't allow for any kind of overhead cost in home production. So if you wanted producing a big meal, a huge meal is just a scaled up version of producing a tiny meal, and there's no like initial constant, if I'm going to cook it all, there's some minimum investment I have to make.
There are the returns to scale. That's how you scale up.
Barn scale has the returns to scale, but there's not an overhead.
No. There's no entry cost. You start with your cooker and your pans, and there's no. Yes.
But this kind of introduction that you gave about the motivation for health, and that's all incorporated in the preference of the child.
This is not necessarily the preferences of the child. This is the
weight the parents give to the child. Is that the reduced form for the outcome?
No. Where are you going with this question?
I'm just trying to link what you're doing with your original motivation.
Okay. So the original motivation is that there is this puzzle in the data. It is interesting to understand it because it links to these broader concerns. I am not taking a stand on the health input here. I am taking a stand on the fact that if we want to understand the dietary choices, we have to account for the shadow price of the good, which is something which takes its place then in the broader debate of the health consequences of investment in children's nutrition. But the model here is silent about this at this point. Yeah? Okay.
And the presumption, this goes back to a previous question, the presumption is that processed food is less healthy. Is that the people talk about quality adjustment and all that, but that's why it's not trivial. Maybe if it's like purchased inputs, it's not obvious.
No, indeed. But I was very careful on that first slide to say that there has been a concomitant increase in the consumption of processed food and in diet-related diseases on the one hand, and also with a lowering of the quality of the nutrition of children. But there is a debate as to whether there are causal mechanisms here. I believe that as time progresses, we will be able to show that there are these causal mechanisms. But at this point, as you know, this is debated. What we do know is that there is a causal link between the quality of nutrition in childhood and later life outcomes. This we know. But as for the link between processed food and the quality of nutrition, it is debatable. And also we can't, in that case, just talk about the quality. We have to allow, indeed, for different qualities. Here, I would like to stress again, the focus is to explain these trends in the choices, where the choices, as I've said, are guided by distinguishing between what requires time for preparing and what doesn't. Yeah?
I guess people are looking for a child health production function somewhere down the line. Anyway, that's not, it's sort of implicit, I guess.
So the solution of the model is going to be a set of Marshallian demand functions, which are functions of full income and the shadow prices. And these describe the relationships between observed market expenditures and market prices and household demographics. And what we see is that the shadow price on home-cooked food depends on market prices, wages, and household size. And what this says is that home-cooked food is more expensive for smaller households and households with higher market wages. So for the empirical implementation, we assume that all households are at interior solutions, and we assume almost ideal demand system functional forms for the demand. The data is the family expenditure survey, which is a repeated cross-section, and we use the 1980 to 2000. Yep. This one.
So P star C is PC, it's observed, right? And
I will show you how this translates into a budget share in terms of the
so what I'm asking, what I want to know is, basically you let 2 extra parameters into P star I and 1 extra parameter into P star X. It seems like you got over-identifying restrictions in the sense that those parameters shouldn't belong in P star C. Do you test those?
Thank you. No. Okay, so we have, there are approximately 200 households surveyed per month, so we have 45,000 observations. We have detailed information on expenditure on different types of food and the outside good. We have information on household composition, demographic information, and incomes, and we also observe labor supply. So there are a number of data issues when going from this share to the share coming out from this model to implementation. So first of all is how to delineate the food groups. So I can show you because you've had interest for this. So we distinguish between 7 categories, where the first one is ingredients for cooking which require time. So such as meat, eggs, fish, vegetables, butter, margarine, pasta, rice, legume, oil, flour. And then we distinguish a different kind of ingredients which can be either cooked or are ready to eat. And then we have the remaining categories are categories of processed foods, where we distinguish between drinks, ready meals, takeaway, eaten at home, meals out, and sweets and snacks. For the price indices, we use the RPI categories, which match quite well with the food groups that we have constructed. Then we construct shares which have to be constructed out of full income. Now, full income is unearned income plus the valuation of total time available for a household. However, in the family expenditure survey, it is not terribly easy to construct Y star from this object, because in particular because net unearned income is often negative, and so we have difficulties constructing this. So instead of this, we construct the total weekly expenditure on all items, food plus the outside good, plus the imputed time of cost with children and time spent cooking. It shouldn't be the time with children. It's the sum of the time with children and the time spent cooking. So this is what we do.
So that's going to be endogenous with what you're trying to estimate, right? That construction.
It is like total expenditure in a standard demand system. Yes.
No, but imputation errors are going to give you endogenous
Yeah.
I don't know if are you instrumenting it in some way?
We're not instrumenting it in some. No, not when we estimate directly. We also estimated a conditional version of the model where we did instrument, but and the results are very similar. But with the conditional version, we can't retrieve the structural parameters, so it's a cost-benefit analysis. Yes. So we also impute wages, and the shadow price of ingredients is going to be, so it's this expression, and so you can see that it depends on the price of the ingredients, well, the relative price of the ingredients relative to the outside good, the wage relative to the price of the outside good, and it depends on the returns to scale parameter and on the conversion factor for time into food. So what we do is that we use, at this point, we're using for the wage, either the wage of the spouse, if there is one, or if not, the wage of the head of household. The idea is that the wage of the second earner, that is the person who's most likely to do the cooking, is going to be the relevant item. So the empirical model, in other words, the model in terms of the observables is written here. Oops. So
can I ask a question? I mean, the last assumption, I think we've talked about it, but so if I have a high-earning husband and the wife doesn't work at all, then you're putting the high-earning husband's wage into this, and that's the shadow price of cooking.
So at this point, we are looking at interior solutions only. This is so we're not looking at that.
I guess it's a question about the data then. So what do you do in that situation where women don't work? What you put the husband's wage in?
No. At this point, we're not looking at the choices of households in which one of the household members is not participating to the labor market. Yes. No, because this would obviously not make sense. No. It wouldn't make any sense at all. In that case, thank you. In that case, I think the relevant parameter would be the evaluation of the value of the time of the non-working spouse. So, yes.
So the trends you showed at the beginning of all households, not just for ones where the...
No, I showed you the trends for the households that we study.
Okay.
Yes, thank you.
Do you have any measure of quantities as opposed to expenditure? I know you have price data and you have expenditure data. Do you have any independent data on quantity?
We have some.
That is on the question of whether wealthier households are paying more per unit?
So that's an interesting question.
But you don't have those data? Or?
I don't believe we can reliably do this at this point. With some work, we might be able to look into that. Yes. So at this point, the empirical results are somewhat preliminary, so we should take them with a pinch of salt. However, there are some interesting and credible patterns which emerge from these results. So prices and household size within this structure explain between 2.3% of the variation in the share of meals out to 20% of the variation in the share of ingredients for home cooking. And home-owned prices are significant in the shares of ingredients, takeaway and meals out. But so, for example, and we see ready meals are substitutes for ingredients for cooking on the one hand and meals out on the other hand. However, as I said, I think that these should be taken with a pinch of salt and are likely to change. So we also have price elasticities where we see that the terms on the diagonal, which are the own price elasticities, are all negative. However, there are some other results I'd rather not comment upon here. But rather, I would like to show you some graphs which, although not with a terrible resolution, are easy to see because all the curves are together. So these graphs show you how well we do in terms of fit of the model. So if we look at the graph on the top, this is the actual decline in the share of ingredients in full income, and at the bottom it's the actual decline in ingredients on the plate, and then the other lines that are superimposed and which are very close are our predictions, so the predictions from the model. So in terms of fitting the data, we are certainly doing not too badly. Also, the reason why there are many lines actually is because we've grid searched on the returns to scale parameter, and we see that not only the fit is rather good, but it is robust to the values for the returns to scale parameter. Now, more interesting is this final piece of evidence is a first step towards a structural decomposition. So the two lines that are together at the top show the actual and predicted shares of ingredients on the plate. So this is just reiterating what I showed you before to say that we did well in terms of fit of the model. The line which is below is a counterfactual prediction from the model, and it shows the share of ingredients on the plate if the price of ingredients had remained at its 1980 value. So in other words, the distance between the two lines is the effect of the labor force participation changes, the wage changes, and the decrease in household size. So in conclusion, what we've seen is that the share of processed food has increased over the period, even though the share of processed food has increased, even though the price of processed food has increased relative to that of ingredients. However, we show that the price of processed food has decreased relative to the shadow price of ingredients. Our model can predict the observed trends in the series of the shares of food types, and a structural decomposition shows that price movements, demographic changes, and labor supply explain together the observed trends. What we are completely silent about is what about skills in food preparation? Because in this story, there is a story about what women do. They go and work, and they earn more, and that's why. And there's fewer people in the household, so that's why they don't cook. However, is it the case that in order to cook, it's not just a question of having the time to do it? Maybe there's a question of having skills to do this. So here we don't have this. And now going back one step to what I was saying earlier, that this is part of the broader agenda about what do families do and the breakdown of family. What are people doing when they're not cooking? Are they investing in the children human capital, and when they're not working? But this time that is spent just putting the ready meal in the microwave and pressing the button, and then what do they do with the time that they would have used otherwise? Are they investing in children human capital? So that's, yes?
You don't allow W, the wages, to show up in lambda, the weight on the utility functions. And that seems to rule out a story of women have higher wages over this 20-year period, therefore they can get more out of the household, therefore they're richer, therefore they buy more time with children.
Absolutely. So there is no reason not to allow for some bargaining, some specialization. There is no reason to not allow for a differential role of men and women in the household on conceptual grounds. At this point, we have developed a model which doesn't incorporate these aspects, but I do agree that I think these aspects would be important and interesting to incorporate as well. However, there would also then be, of course, the next question would be, what about the dynamics? And yes.
I guess if you were doing, perhaps I missed it, but if you were doing a full-time allocation model, and if you thought these different uses of time are not perfectly substitutable, then kind of the core solution is the labor market. the corner solutions for women working or not working, and the impact of that on the relevant price of time might be important. So if the woman is on a corner,
Okay, the corner.
yes,
It would just sort of put children and some of the other constraints as a direct determinant of that shadow price.
yes,
And that would, it's going to maybe break some of your identification, but it would
Yes.
give you some additional power. Although you're saying the number of children is declining, so that's going to be a factor probably towards working against. But
it would give you a more accurate
no.
estimation of the shadow price.
yeah, I'd just be worried you're throwing away a lot of the data, though. I think the way I understood what you said in the answer to one of the questions, that for the non-working women, they're not in the sample. So that's a fairly big chunk here.
I agree. So, as we saw when we at the start of our period of analysis, it's 45% of women are participating. At the end of the period, it's 70%. So this is a very significant concern. So because of this, we developed a conditional version of the model a la Browning-Megier, where we condition on labor supply, where we don't have to assume that there is a constraint. And this way we could incorporate non-participating individuals. However, and I have to say we estimated the model and we get qualitatively very, very similar results. But what happens in the conditional approach, because there is no one-to-one correspondence between the conditional and the unconditional cost function, you can't, from the estimates of the conditional model, recover the structural parameters of the unconditional model. And it seemed to us, so this is really a question, it seemed to us that telling the story in terms of the shadow price, even if we lost a large part of the sample, was very important, as opposed to the conditional approach where we could do counterfactuals which didn't modify labor supply, but we couldn't have the story in terms of the shadow price.
But you can do both. I mean, in some sense, you have the conditional approach, and then you could have the model of labor supply and put it together. So I don't see quite the trade-off. Right?
Okay.
Thank you.
Thanks very much.
The next paper is